Hello, in this tutorial I'm going to explain how to use scripts in Metabolab, particularly when Metabolab is being used either in a container or in Galaxy. I have a sample directory here. The Brooker data is in Brooker_data. If we have a look at that, hopefully you can see there are 3 experiment numbers, so basically 3 spectra to be processed. If we have a look at the script, the script is divided into a number of sections, so each section begins with a section name and ends end section name. So this first section here is concerned with reading in the raw data. Throughout this script, all paths need to begin /mydata because this script is to be used in container and in Galaxy. So all paths must begin /mydata. And in this case, the raw data is in this directory Brooker_data, so that goes into the path, and the data sets, the experiment numbers are 1, 3 and 5. With a different data set, we could specify the data sets or the experiment numbers explicitly, or we could just set data sets to all to read in all the experiment numbers, or we could set data sets to odd to read in just the odd experiment numbers, or to even, and so forth. Okay, so once you've read in the data, you need to set up your processing parameters. So the next section is concerned with that. So for example, you can see here WDWF is the window function. So EM is exponential window function, LB with a line broadening of 0.3 Hertz. So SMO is specifying the water suppression. So in this case, this is a convolution filter because SMO is set to 2. And then under SOL, the parameters for that window function, so for the convolution filter, are set. Autophase is set to 5, so that uses the APK5 autophasing algorithm and begins from the current 0 order and 1st order phase corrections. So ZF 0 filling is set to 131,072 points. And then ref, this is the referencing of the spectrum. So if ref is set to water, then the middle of the spectrum is where the water peak is. And if it's set to auto, then the spectra are referenced on DSS or TMSP. And then at the end, there is an option to do an automated baseline correction, if that's set to 1. Okay, in the next section, then the 1D spectra are processed. Following processing, you need to set your pre-processing parameters, preparing your data for multivariate analysis. So there are a lot of options here. I'll just explain a few of them. So this align CS max shift basically sets the maximum number of points you can move the spectra in order to align on TMSP or DSS. Then you have a choice of either a baseline, spline baseline correction, or an automated baseline correction with some associated parameters for that. It's common in pre-processing to exclude certain regions of your spectrum. So here, the region of the spectrum above 9.5 ppm is excluded. The region of the spectrum between 4.6 and 5.2 ppm, that's basically the water region, is excluded. And the region of the spectrum above 0.5 ppm, below 0.5 ppm rather, is excluded. There's some segmental alignment options here. So this would be more commonly used in the graphical user interface version of Metabolab, but you might wish to say you have some peaks are moving around because of some subtle differences in pH. You may wish to specify a certain region in which you want to align the biggest peak. So here there are 5 different regions selected for segmental alignment. Commonly, people also wish to bucket their spectra, and you can set your bucket size either in ppm or in points. If both are defined, then the ppm specification takes priority. Commonly, people wish to do a generalized logarithmic transform to increase the weighting given to weaker peaks in the spectra, so there are some parameters for that here. And then if you wish to noise filter your data, you need to specify a noise threshold and also define the region where the noise will be measured. Finally, this move spectra between workspaces is usually set to 0, but if you have a large data set and you need to save memory, then that parameter should be set to 1. So once you've defined your pre-processing parameters, you need to specify which of your pre-processing steps to execute. So pre-processing operations set to 1 are executed. Those set to 0 are not executed. Generally, the pre-processing operations are carried out in order, in the order given. However, if numbers greater than 1 are used, then the pre-processing operations are carried out in ascending numerical order. So once the pre-processing has been carried out, then the last 2 sections are just giving some details about creating isotab files. So that's for submission to metabolites. So for that, if you have no metadata, then the file name should be nometa.txt. But if you're working within the graphical user interface version of Metabolab, you may have generated there a file containing metadata, which would be specified here. So for containers and for the Galaxy version of Metabolab, this should be nometa.txt. Again, don't change the path and don't change the name of the map file if you're in a container or in Galaxy. So I think that concludes the explanation of the scripts used in Metabolab. Thank you.